Hi there. So in this video I want to talk about dividing polynomials by monomials. Okay, and so this works a lot like it does with multiplying. All right, so let's just look at an example of this. And so let's say I have something like 18x to the fifth, and I want to divide that by 3x to the third. Okay, like that. Now in this case what we're doing is this is actually two monomials. So I'm dividing a monomial by a monomial like that. All right, and so this is a basic example, but like we saw in the last video, whenever I have products in a fraction, I can break that up so I can group together the number part, okay, 18 over 3, and I can group together the variable part, x to the fifth over x cubed. Again, if you don't see why you can do that, think about going backwards. If we started here, we'd be multiplying two fractions. We'd multiply straight across to get this expression right here. Okay, and now why is that advantageous? Because we can say what we have in terms of the numbers. 18 divided by 3 is 6, and here we apply the exponent law. That's exponent law number 4, so I subtract the exponents. So I have x to the 5 minus 3, and so this would be 6x squared. Okay, like that. All right, so the basic thing we're getting at here is that whenever we take a monomial and we divided it by a monomial, and just remember that fraction bar means divide, like that, okay, then we can group the numbers and group the variables. Now sometimes we'll have more than one variable, so we want to group the variables by their name. All right. Now the thing is, before with multiplication I said multiply the coefficients and add the exponents. And right here I'm not saying divide the numbers, okay, because a few things could happen. We divide if possible. That's happened in the example above, okay, or sometimes we need to reduce, okay, and so or reduce, or you just leave it as a fraction if it doesn't reduce at all. So a few things could happen there. But then once we group the variables, then we apply law 4 and we subtract the exponents, okay, like that. And the reason for that is that we're applying exponent law number 4. All right, so let's look at a couple examples of that. Okay, so here's an example, 4x to the fourth over 6x to the third, and so we can group together the numbers and then we can group together the variable part like that. All right, and see, this is a case right here. There's no even division there. 4 doesn't divide evenly by 6, but it does reduce to 2 over 3. And then here I subtract my exponents, 4 minus 3, and so I get 2/3 x to the first. Okay, but just remember, whenever our exponent is 1, we usually don't write it. So this is the way we would preferably leave our answer. Okay, and then I could have something like 5x to the ninth over 15x. Okay, and so again, we group together our numbers. 5 over 15 is times x to the ninth over x. And just remember, since my exponent's not written, that's really a 1 to help you remember what to subtract. Now here 15 does divide by 5, but we're not doing 15 divided by 5. We're doing 5 divided by 15. So in that case we would reduce by 5. All right, and so we would divide each one of these by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So we get 1/3 for our number. And then here we would do x to the 9 minus 1. And so we would get x to the 8th. So this ends up being 1/3 x to the 8th. Okay, and then let's see one more example with several variables. Say I have 7x to the ninth, y to the fifth, and I want to divide that by 8x to the fourth, y to the fourth, like that. Okay, and so in this case, since I have several variables, first of all, I'll just group my numbers like we've been doing, and then I have x to the ninth over x to the fourth. I want to group my like variables. Remember, the reason we're doing that is to apply law 4, you have to have the same base. So we've grouped it so that in things that had the same base. Now 7 over 8, there's no even division or reducing there, so we just leave it as 7 over 8. Okay, here I do x, I subtract the exponent since I'm dividing, so I have x to the 9 minus 4, that's x to the 5th, and then here I have y to the 5 minus 4, that's y to the 1st, but as always we don't write the 1 there, and so this is what we would list as our answer. Okay, I'm going to fit in one more example over here. Sorry if that's a little confusing, but one thing I just thought of too. All right, so say I have, I'll just do a simple one. So say I have 20x to the 5th, and I divide that by 5x to the 5th, like that. Okay, so I would still break it up into 20 over 5 and x to the 5th over x to the 5th. Okay, so 20 over 5 is equal to 4. There's an even division there. Now what goes on here, if I want to apply the exponent law, we would have x to the 5 minus 5, which would be x to the 0. But if you remember exponent law number 5, anything to the 0 is 1. So this is 4 times 1, which is equal to 4. The other way, you can actually skip that exponent law part from here to here. Just if you realize that you have something divided by itself, that's equal to 1. So you also have 4 times 1 that way. Now we can look at a more general case, and this brings up an important algebraic concept that students often forget, and as they go through algebra classes, they always forget this basic idea. And the basic idea is that division also distributes. So it's a big thing. So we usually think about using distribution with multiplication, but distribution also applies to division. All right, and so what I'm talking about here, let's look at a very basic example. Let's say I have 12x plus 8, and I want to divide that by 4 or over 4. And so the key thing to remember is that fraction bar actually means divides, like that. And since division distributes, that means that I can distribute that 4 on both sides of that numerator, like that. And so this is an amazing fact, and it'll help you with a lot of algebra later too, is I can think about this as being 12x over 4 plus 8 over 4. Now, one other thing to remember too is that numbers can be viewed as monomials or polynomials. They just have degree 0. So this is a polynomial, and I'm dividing it by a monomial. And the way to do this is we distribute that monomial over to each term of the numerator. Okay, and so now this one's a really simple one, but if we followed what we did a minute ago, this first thing is really a monomial divided by a monomial. So I could group together my numbers, and I could group together my variables, but we only have one variable. There's not a denominator. The denominator doesn't have a variable. Now 8 over 4, that's 8 divided by 4, so that's equal to 2. Now all we have left is to take care of this 12 over 4, but that's an easy division. That's 3x. And so our answer ends up being 3x plus 2. Okay? And so the idea here is that whenever you have a polynomial divided by a monomial, you distribute the denominator under each term of the numerator. And then you'll just have a bunch of monomial divided by monomials to compute. All right, so it's pretty straightforward. Let's look at some examples. Okay, this first example is pretty basic, but it also it'll point out a very common mistake that we have. But anyway, notice that we have a polynomial, and it's divided by this monomial, 9x. And so what that means is I can distribute that denominator into each term of the numerator. Okay, and so I can think about this as being 3x squared over 9x plus 9x over 9x. Okay, so now notice, if you didn't catch on what I was saying a minute ago, here's a monomial divided by a monomial plus a monomial divided by a monomial. So see that we're just layering everything, and we know how to divide monomials by monomials. So you just treat it like it's two separate problems if you need to. There's this part and there's this part. Okay, and so remember the idea is that you group together the numbers and then you group together the variable parts. Okay, group together the numbers. There's a shortcut on this second one, but I'll show you that in a moment. Okay, like that, but just following our normal format, we would separate out parts. Now be careful, students will often say that this is 3, all right? This is 3 over 9, not 9 over 3. So this is not equal to 3. You got to reduce that. And so we reduce that fraction. We divide top and bottom by 3, and so we get 1/3. I made a mistake in my writing there. This is x squared divided by x. Sorry about that. Okay, and so so now I have, remember this is x to the first, so we have x to the 2 minus 1. That's x to the first, but we typically don't write it. I'll go ahead, I'm going to need another line anyway. Okay, now in my second one I have 9 divided by 9, which is 1. Okay, if I wanted to follow the exponent law, these exponents are both 1s, so this would be x to the 1 minus 1, which is x to the 0. Okay, so remember that this is 1, so I really just have 1 times 1. So putting this all together, I get 1/3 x plus 1. Okay, so now, very important thing about that tail part before we move on. Okay, another way you could, with this tail part, the 9x over 9x, like that last example we talked about a minute ago, you don't necessarily have to do anything, right? Or you don't have to do these steps right here. What do we have? We have something, 9x, divided by itself. Anything divided by itself is equal to 1. So for this part right here, we could have just jumped straight down and said that that's equal to 1. One important thing, though, is I've seen this with students so much in the past. They'll have this, and they'll have this, like that. They'll handle this part fine, but then for some reason, they'll cancel these things out, and they'll say plus 0. Okay, something divided by itself is equal to 1. It's not equal to 0. So this stuff right here is just very wrong, and it makes your poor math teacher cry whenever they see that. So take it easy on your math teacher. Okay, and so now let's see, let's look at one that has 3 terms. So say I have 8x to the 4th minus 3x to the 3rd plus 2x squared. And then I want to go and divide that by 2x. Okay, like that. So this has 3 terms, but distribution still works the same way. And so we're just going to distribute that 2x over all of these, all 3 of these terms. And just take it nice and easy and don't rush the process. Some people can do a lot of this in their head, but I also see them frequently they say silly errors, but it's only silly because they're not slowing down. Okay, and so then now make sure you realize, where did this minus come from that I just wrote? And so let's erase my distribution lines real quick. Oops, I erased too much, didn't I? Okay, like that. So what's going on here is that this numerator has a subtraction in it. So I just carry it down. So if you're having trouble seeing that, this subtraction sign is that subtraction sign. Okay, and then what do I have? I have 3x to the 3rd divided by 2x. And then lastly, I have plus 2x squared over 2x. Okay, like that. And so now again, the idea on each one of these is to break up each part. On the first part, since you're dividing by x on all of them. If it helps you, write that as x to the 1st. All right, and then we group together our numbers and we group together our variables, like that. And then we have 2 over 2 and x squared over x to the 1st. Okay, so 8 divided by 2 is 4. And then here we subtract the exponent, so it's x to the 4 minus 1, which is 3. Minus 3 over 2 doesn't even reduce, so it just stays as 3 over 2. And then I do x to the 3 minus 1, so that would be x to the 2nd power. Okay, now be careful here. We have 2 over 2. Anything divided by itself is 1. Okay, and then we have x to the 2 minus 1, So we would get x to the first. All right, and then over here on this tail end, we just want to clean things up. 1 is our coefficient, so we don't write it. Well, first let me write these first two. So 4x to the third minus 3/2 x to the second. And then we have plus 1x, but since we don't usually write that 1 out front, that's typically how we'd write the answer right there. Okay? All right, so let's look at one where we divide by a negative monomial, and it's no big deal. Don't overthink it. Everything works the same. It's just we'll have to keep up with signs. So we still have a monomial in our denominator, so we can distribute it. All right, and so we have 9x to the fifth over negative 3x squared. Now be careful here. There's a minus in our denominator, so we just write that. Okay. But what do we have? Minus 27x squared over negative 3x squared. Like that. Okay. Now there's, well, let's handle that first one first. So we have 9 over negative 3, and we have x to the fifth over x squared. Okay. Like that. And then we have minus 27 over negative 3 times x squared over x squared. Okay, like that. And so you can just follow 9 divided by negative 3. That's 9 divided by 3, which is 3. But then I have a positive divided by a negative, so that's going to come out negative. And then I have x to the 5 minus 2, so that's going to be x to the third. Okay, and just what I would do is I just keep your minus, but 27 divided by negative 3 is going to be negative 9. Okay, so there's just a few negatives to keep up with, but that's okay. All right, so make sure you realize what's going on here. This minus just got rewritten because it's a subtraction, and then 27 divided by negative 3 is a negative. So we just have these two negatives. Now, what's anything divided by itself? It's 1. You could use the exponent laws like I've shown you, but you don't need to. Just anytime you recognize something divided by itself, it's equal to 1. Okay, now what have we been saying? Now we have two negatives. So they're going to make a positive down here. And so we have negative 3x cubed plus 9 times 1 is just equal to 9. Like that. So this ends up being our answer. And if you look, notice what happened, and we pointed this out, whenever we distribute a negative, the signs inside the parentheses change. In this case, what resembles the parentheses is the numerator. So notice my numerator started as plus minus. After I distributed that negative, they reversed. They became negative plus. So that's at least a sign check you can do to catch that, to catch at least sign errors. All right, 2 more examples. One with just dividing but with a negative, and then one where we have more than one variable. Okay, but the idea is that we have a monomial in our denominator, so I can distribute it to each part. And so I have 18y to the 9th over negative 6y to the third. Okay, now my numerator has a minus in it, so I put a minus here. And then I have 6y to the 5th over negative 6y to the third. Okay, and then also notice there's another minus in my numerator, so I'm going to get a minus. And then I get 21y to the third, but I'm dividing by negative 6y to the third. Now, I meant to point this out in the last video. You might recognize now that you're going to have these two negatives, so you could just change that to a plus and get rid of all your negatives. Okay, it's up to you how you want to progress. And so I'll show you how we can do that. But we have 18 over negative 6, y to the 9th over y to the third. Okay, so if we recognize here that we have these two minuses right here, they'll come down and make a plus. Okay, like that. And then I don't have to worry about those negative signs. I just have 6y to the 5th. Oh, I'm sorry, I'm grouping things. So we have 6 over 6. See, I'm not using the negative anymore. And then y to the 5th over y to the third, like that. Same thing here. I have these two minuses right here. I can use them to make a plus. And then I have 21 over 6, y to the third over y to the third. All right, like that. All right, and we're almost there. Now we're ready for 18 divided by negative 6. That's an even division. We get minus 3. and then we have y to the 9 minus 3, like that, and so that's going to give me y to the 6th. Okay, right here I have 6 divided by 6, that's 1, and then I have y to the 5 minus 3, so that's going to give me y squared, or y to the 2nd. Okay, now we have 21 over 6. 21 doesn't divide evenly by 6, but notice that they both divide by 3, like that. Okay, and so here I'm going to get 7 over 2, and then notice here I have y to the 3 minus 3, which is y to the 0, which is equal to 1. That's how you do it with the exponent law, or just realize you have something divided by itself, and so that's going to give you times 1. Okay, like that, and then just clean up where all those 1's are. So we end up with negative 3y to the 6 plus 1y squared, but we usually don't write 1 as a coefficient. All right, and then plus 7 halves times 1 is just 7 halves. And so that would be our answer to that problem. All right, so here's an example with several variables. There's two variables here, m and n. Okay, but make sure you realize there's nothing different, just a little bit more complicated, so it's going to require a little bit more care, but we have a polynomial divided by a monomial. So we still follow our same steps. We can distribute that monomial to each one of the parts, all right, like that, and so let's do that. And so we have 14m to the 8th n to the 6th over 7m squared n, and then plus 21 m to the 6th n to the 8th over 7 m squared n. Now one thing too, remember if we don't have an exponent written, it's 1, so you might need to want to write it just to remind yourself of that. Now this third part has a subtraction, so it's minus 7 m squared n cubed over 7 m squared n. Okay, now if you want to, you can put that step in where we've been breaking stuff up, but it's not really always needed. You can think about just separating out each one of the parts there. I know that looks a little bit sloppy. Oops, yep. Okay, so lesson learned there, but so I'm going to go ahead and do that since this is looking so sloppy there. But you don't necessarily need to do this next step if you can separate them out in your head. So this would be 14 over 7, but if it does help you do it, do whatever you need to help yourself. And then we have m to the 8th over m squared, and then we have n to the 6th over n to the 1st, like that. And then plus we got 21 over 7 m to the 6th over m squared, and then n to the 8th over n to the 1st, and then minus 7 over 7, then m squared over m squared, and then n to the 3rd over n to the 1st. Okay, like that. And so now you just go one piece at a time. 14 divided by 7 is 2, and then here we have m to the 8 minus 2. That's going to be m to the 6th. And then we have n to the 6 minus 1, so we're going to get n to the 5th. Okay, go to the next term. All right, 21 divided by 7, that's an even division, it's 3. Okay, and then here we have m to the 6 minus 2, so that's going to be m to the 4th. And then n to the 8 minus 1, so that's going to be n to the 7th. Okay, minus, we have 7 divided by 7, that's 1. Remember, everything here is being multiplied. We have m squared divided by m squared. If you wanted to use the exponent law, you would get m to the 0, or just realize you have something divided by itself, so you get n 1. Okay, and then here we're going to have n to the 3 minus 1, which would be n squared. All right, just clean up that last part and we'll call it good. So we got 2m to the 6th n to the 5th plus 3m to the 4th n to the 7th minus, these 1's don't change anything, so it's just minus n squared, like that. Okay, and you can see we took a very complicated looking problem, and just by going step by step, we carried it out fairly efficiently. All right, I hope that makes sense, and let me know if you have questions. All the best.